Hello, welcome everybody to my introduction of ORT, the OSS Review Toolkit, in the context of the OSADL COOL lectures. My name is Sebastian Schubert. I'm the founder of ORT and by now a self-employed IT consultant in all things open source, basically focusing on compliance and security topics. Before we get into the details, let me start with a few more words about myself. So I studied computer science at the universities of Braunschweig and Berlin. Back then, I focused on computer graphics, robotics, and cryptology, so no open source specific topics yet. But I quickly became an open source enthusiast simply because I wanted to fix bugs in software that I use myself, which means I started to use more and more open source software because that did put me into the position to be able to fix bugs myself. So by now, I'm currently contributing to a lot of open source projects actually, and by GitHub measures, I do about 3,400 contributions a year, both code contributions and a lot of reviews and bug reports and stuff like that. Over the years, I gained a wide network of trust. So I'm reviewing code in about a dozen of GitHub organizations. And partly I actually review more code than I'm writing code. I also have quite a few years of experience in developing proprietary software. So I did a lot of things ranging from high performance computing stuff to low power mobile apps. And in general, I'm an automation freak, so to say. I like to automate away the boring stuff. I like paradigms like configuration as code instead of fancy clickable GUIs. And in general, my motivation in day-to-day work, or especially in the context of compliance automation, is to take out the process pain of software development. At heart, I'm still a software engineer, and I feel the pain of engineers that have to deal with this kind of processes, which are mostly manual. And also, I like to bridge the gap between the open source communities and proprietary software development because my heart basically beats in both areas. And I understand both sides, which are often more seen like opponents than people working hand in hand. And I'd like to advocate for an open and transparent engineering culture and breaking silos between teams and companies, for example. I guess you guys are well aware of the problem statement, but nevertheless, let's quickly recap the problem that we are trying to solve. So in the beginning, we have an application, most likely a proprietary application that we're developing. And this application has first level dependencies, direct dependencies. But these dependencies often have further dependencies, transitive dependencies. And these days, these dependencies are highly likely to be open source dependencies. In a typical software stack, you have something like 80 to 90% of open source involved, which means you have to deal with a lot of licenses. Your application is proprietary licensed, but then starting with the direct and transitive dependencies, you might come across a lot of open source licenses. And while these don't come with license fees in the classical sense, you do have a cost in the sense of adhering to license obligations. So since it's you distributing the application, it's also you creating the mix of licenses. So you have to take care that you don't create a mix with incompatible licenses. Luckily, Groups like OSADL have means at hand that ease this checking quite a bit. For example, with the OSADL license compliance matrix. So in this matrix, you can look up incoming and outgoing licenses and can figure out whether they are compatible or not, or whether it's maybe unknown whether they are compatible, or whether it depends on the context whether they are compatible. But even with fancy tools like this matrix, some questions arise. Like common pitfalls are, which pairs of licenses do I need to actually look up in this matrix? So traversing through the dependency tree, that's not immediately clear. Do I always pin the root license and check dependency licenses? Do I need to check different dependency licenses against each other and things like this? A common misconception also is that it would be enough to only care about direct dependencies. That's not actually true. Transitive dependencies might be distributed as well, especially if things like static linking are in place. So you do need to care about transitive dependencies. Also, relying exclusively on the declared license that often comes from package metadata is not sufficient usually. You have to at least invest some best effort to double check the license that has been declared and look at the so-called detected licenses that are found by license scanners, for example. And finally, especially engineers often complain about this craziness and believe it's just due to some company policies. But in the end, no, this is actually about law, and in German, especially the Urheberrecht. So it's not something you can ignore or just switch companies and try to get rid of it. So this is starting to get complex. Please give me some tools to automate this away. And this is where it all started back in 2016. A group of people at Nokia back then, or HERE Technologies, were evaluating tools to automate license compliance checks. We were looking at a lot of tools, both, of course, the usual suspects from the commercial vendors, but also some open source solutions. But it quickly turned out that there is no single good fit for all requirements. No single tool fits all needs. And for the tools we were looking at, often dependencies were not correct. Either the dependency tree was not fully resolved transitively, or not all scopes were considered. You have dependencies that only apply to compile time. You have dependencies that are only test dependencies. You have dependencies that are only bundled at runtime. And these are also maybe to be considered depending on the context. And finally, many of the tools, even the tools that occurred recently, don't take things like version conflict resolution into account. So dependency versions may change dynamically with what has been declared in the build system to resolve version conflicts if the same dependency occurs multiple times in the tree in different versions. And that is something that very few tools are able to take into account. Many of the tools are also not configurable enough. It was still the case back then, and it is now. So, for example, when it comes to policy rules, you want to have big flexibility to implement the rules that you need in your company. And also when it comes to customizing attribution documents, for example, most of the tools are very limited. So if you want something like a company-themed attribution document with a nice logo and your custom font and whatever, then you are usually out of luck with many of the tools. And finally, a typical drawback of the commercial tools is that you have the usual vendor lock-in. So if you invest in switching to a tool, it's very hard to get it out of your software stack again. Commercial tools are usually a complete black box. You don't know what's happening inside. So you just put in some input and you get some output out, but you have no clue sometimes how the tool came to this conclusion and the output that is being shown to you. And finally, the data that you're creating, the scan results that you're creating, it's not your own data. It's basically belongs to the vendor of the tool. So the decision was made to build our own tooling. And the goal in the best spirit of open source was not to reinvent the wheel, but to fill the gaps of what we see in the tooling landscape to be missing. We also wanted to abstract away the tools that we are using to swap them out easily and to ease comparison between tools or migrations from one tool to the other. Also, in the spirit of the Unix philosophy, we wanted to focus on one thing and do it well before we start to do other things. Another important aspect, especially for engineers, technical people, is that the tooling should run equally well on CI and locally, so that you can easily reproduce locally the results that you get from CI. It's very annoying if you're looking at results and you're not able to comprehend what's happening, or you're not able to reproduce some issues because the tooling only runs on CI, and that doesn't give you enough insights. We wanted to have a result format that is both human readable and machine readable, and the results in general should be comprehensible. So I started out writing a prototype that was back then a loose collection of scripts per language and package manager. So there was a dedicated solution for Gradle written in Groovy, for example. There was a Python script for pip. There was some Ruby scripting for bundler, just to demonstrate the concept to abstract these things away and to analyze dependencies for different package managers, providing the same unified output. And as this turned out to be working, the new tool that was rewritten is basically ORT 1.0. So instead of this loose collection of scripts, a unified tool was written in Kotlin, which was a fancy new language back then that I wanted to give a try. And it turned out to be a good choice by now, actually. So what is ORT? By definition of the book, ORT is a suite of tools that aims to assist with the tasks that commonly need to be performed in the context of license compliance checks. So back then, we clearly focused on license compliance checks. The scope extended a bit, but I'll come back to that later. And also, one important bit, especially in this round, probably is that the focus clearly is on applications. I will also come to that bit later again. By now, ORT is being used or at least evaluated by several bigger companies. So sorted alphabetically, there is, for example, Alliander, Bosch, BMW, Car IT, Carriot, EPAM, Here Technologies, Lectra, Porsche, and several others. And also probably a lot of companies that we're not aware of, because only occasionally we get support requests from companies that we've never heard of before, but then they're telling us, hey, we've been using ORT for a year or so internally. So there is probably a big dark number of ORT users out there. Also, by now, the scope is being continuously extended. So beyond the strict needs of license compliance checks, we also do security checks by now. You can use ORT also for commercial license management, because actually there is no technical restriction inside of ORT that requires you or limits ORT to the use of open source licenses. In the end, it's only about licenses and their obligations, and these could also be commercial licenses. And also another thing you can use ORT for by now is checks for open sourcing your own software. So it's like pre-open source checks if you want to have some clearance about projects that you as a company are going to open source. These kind of checks can also be implemented with ORT and the evaluator tool, which I will talk about in a few minutes. What is ORT then not, at least not yet? ORT is not a legal workflow tool. So it's not a tool for legal people that shuffle around documents. There also is no fancy GUI yet to interactively work with the results. We have a bunch of reports that we can write out, ranging from SBOMs to React-based web app reports, but these are non-interactive, sort of. You can browse the results and filter the results, but you cannot really act on the findings yet. And finally, I hope this is not turning you guys off too much now, but ORT was not designed for checking compliance of Docker images or Linux distributions. So that's what I was meaning to say on the other slide about applications. ORT focuses on modern software development with dedicated dependency management and those package managers that are involved in that area. So what's the goal then? Our goal is to highly automate open source compliance checks. We will never be able to fully automate these checks. At some point, we will always run into problems where a human being needs to interact. That's why I'm saying highly automate open source compliance checks, which in the end boils down to the need to fulfill open source license obligations, like do we need to redistribute the source code, create attributions to the copyright holders, and check license compatibility in general. Which forces us to analyze the project dependencies, and as another step after that, also download the source code in order to scan the source code of dependencies for copyright holders and for licenses being used. So this is the place where we can then double check and compare declared versus detected licenses. And then once all this metadata has been collected, we can run the evaluator to evaluate our company rules that may implement license compatibility checks or any other company internal policies, actually. And finally, the last step is to document our findings via the reporter tool and write out things like SBOMs or disclosure documents or whatever you need, actually. Following the workflow, these are the ORT building blocks. In the first step, there is always the analyzer. The analyzer is a more or less classical software composition analysis tool, but I will come to the specialities of it a bit later in a dedicated section. The advisor tool is a tool that can be used to find known security vulnerabilities or also defects in the identified software components. Then there is the scanner, which implicitly uses the downloader to extract license and copyright information from the downloaded source code. The evaluator tool that implements the policy checks, and finally the reporter tool. So this very much resembles the workflow that we've seen before. Coming to the details of the analyzer. So one of the big goals of the analyzer was to inspect projects from the outside, which means, in contrast to many of the other solutions, there are no build system plugins by design. And that is so to avoid a vendor lock-in, sort of also with open source, because once you invest a lot of time to switch your build system to using certain plugins, you probably don't want to remove that code again and switch to something else. Also, a benefit of not being dependent on build system plugins is that you can analyze any project that is not under your control, like third-party open source projects. The general paradigm of the analyzer is to first analyze everything, even stuff that you may deem unimportant or not necessary in this context, like maybe test dependencies or so, and then later filter the data. So we first want to get the full picture and later on only filter down to the needed scope of information. This approach also takes into account the earlier mentioned version conflict resolution. So instead of, again, many other solutions that just statically parse so-called definition files like Maven POMs or package.json files for NPM, these tools cannot really take dynamic version conflict resolution as it happens in the context of the specific project that you're looking at into account. We by now support about 20 package managers or ecosystems, and among those there is Conan, Go, Java, JavaScript, .NET, Python, Ruby, Rust, and several more. However, we also have a fallback for software projects that don't use dedicated package management and that don't have machine-readable package metadata configured, which is SPDX documents. So we cannot only output SPDX documents as SBOMs, we can also use them as input as a substitute for the lack of machine-readable metadata. So you would basically create an SPDX document that documents your dependencies and use that as the input for the analyzer so that all subsequent steps just work. If you're wondering what kind of metadata we are collecting in the analyzer, here is a brief example output. I hope it's readable. The font is maybe a bit small, but just to give you an idea. So we have the package identifier, both in our own format and in the package URL in the Perl format. All of this is there. Declared license is there in the exact form that the package uses. So in this case, you see the declared license is a free text string that for a human being obviously shows the Apache license, but ORT is able to normalize that to a valid SPDX expression using SPDX IDs. We have the description, homepage URL, and the artifact URLs as well, plus some more metadata that didn't fit the screenshot, like VCS information about a source code repository if present. Next, there is the advisor. So the advisor can not only actually advise about security vulnerabilities, but also about defects like bugs, because you may also be interested in how many open bugs are there in this open source software that I have in my stack. We support several providers. Among them is Google OSV, Vulnerable Code, OSS Index, and its commercial sibling Nexus IQ, and GitHub in general. So GitHub is implicitly contained in Vulnerable Code. So the GitHub security advisories are pulled in by Vulnerable Code, but we can also work on GitHub issues for defects management. Again, there is a small screenshot to give you an idea about how we reflect this in the serialized data model in YAML format. So there are some advisor results for JUnit, and there is a vulnerability reported against that JUnit version, and we record the reference URL, the scoring system, severity, and so on. And on any of these metadata fields, you can then later on act upon in your evaluator rules. The scanner in ORT actually is not a scanner by itself. Remember, we didn't want to reinvent the wheel, and there are good open source scanners out there, especially ScanCode, which is the default scanner that we are using in ORT. So the scanner serves as an abstraction layer for multiple scanners. The scanners that we support out of the box beyond ScanCode are Licensee, which is the scanner that GitHub itself uses to scan licenses and show this badge of which license is being used on the GitHub projects page, and Ascalono, which is a scanner from Amazon. Beyond these typical license scanners, we also support a few snippet scanners. So snippet scanners identify code that has been copied and pasted from other open source projects, which is something fundamentally different than just searching for copyright headers in source code files or inside of license files. For snippet scanners, we currently support FOSS-ID, which is a commercial tool, and ScanOSS, which is both open, partly open, and has also a commercial offering. Yeah, and finally, the downloader is just being used programmatically to download the source code from the VCS or source artifact, but the downloader also exists as a separate tool to download, for example, the project source code initially, but it wasn't worthwhile mentioning it as a separate tool here, so it's just mentioned as part of the scanner, basically. Again, a brief screenshot of the scanner output. So in this case, we scanned a Java library called Semver4J. Coming from GitHub, we record the exact revision that has been scanned, the scanner that has been used for scanning in the version, and with the respective configuration, because depending on the configuration, scan results may change, and we are very eager to have comprehensible and reproducible results and be very transparent about how things are called and happening inside. And then we can see, for example, that in the POM XML, we have a declaration of BSD3 clause license. And additionally, we have a declaration, or sorry, a detected MIT license in the license MD file, including line numbers. Next comes the evaluator tool. This is a freely programmable tool with a Kotlin DSL. So you write scripts in Kotlin that have full access to all of the metadata that all of the tools that ran before assembled as part of the ORT result. And this is where you can implement checks that are not limited to open source licenses necessarily, because you can do checks that are totally unrelated to open source. Also taking into account license classifications that come from a separate configuration file. But inside of this file, you can just put labels on licenses, for example, associated to their obligations, and these obligations do not have to be open source obligations. This is how a DSL may look like. So this is a very simple rule that just checks that there is no copyleft license in the source code, and it excludes all findings that should be excluded by our project configuration. And it is only triggered if there is a copyleft license according to the license classification that we have. And if so, it will write out an error message plus an optional how to fix hint for the developers, how to address the problem. In the end, finally, the reporter tool comes into place. So the reporter tool is a very generic tool that is also, like any of the other tools, by the way, extensible via plugins. We can write out fully nicely themed PDF attribution documents, classic plain text notice files, HTML reports, SBOMs in various formats like SPDX and CycloneDX, or some plain, basically pre-baked JSON for further processing. And each of these reporters also supports format-specific options where you can tweak some details. This is how the web app report looks like. It's not a very complex project. In this case, we only have 3 declared licenses. Usually you have, unfortunately, a bunch of more than that, but just to give you a brief idea. Then we have some tabs at the top where we can browse dependencies in a tree or in a table view and filter by various aspects of the dependencies. When it comes to integrations and integrating ORT in your CI/CD pipeline or infrastructure in general, we have some prepared integrations. For example, for Jenkins, there is a declarative pipeline that uses Docker build steps, where you can nicely see how the pipeline is composed of the different ORT tools that are being run. We have some integration for GitLab CI, including a video that has been provided, thankfully, by GitLab, themselves, and some GitHub action that you can integrate in your workflow. Another companion tool that we offer as part of the ecosystem is the ORT Workbench. It's a pretty young project still. We have a lot of ideas how to improve it, but too little time to actually implement all of our ideas. But it already serves as a nice browser for ORT result files, and it can handle larger files than, for example, the web app report, and the plan is also to make it interactive in the midterm. So you can maybe do things like right-clicking on a result and mark a license finding as a false positive and stuff like that. Another outlook about the tools that are going to be created in the ORT ecosystem is the ORT server. So the ORT server is going to be both the backend and the front end. That is an alternative basically to the CLI front end that we currently have for ORT. And one of the main goals is to address scalability. With a permanently running server, you don't have ramp up, ramp down times when provisioning build nodes with Docker images and this kind of stuff. And hopefully it will also simplify the setup and workflow in several integration scenarios and CI/CD environments. The work has started mostly by Bosch. The source code is not public yet, but the aim is to make it public in the second half of this year. And this actually concludes my talk about the introduction to ORT, the OSS Review Toolkit. Thank you all for listening, and now we're open to questions.